Okay, today we're going to be translating some algebraic expressions and creating and solving. The first part of your notes, we're just going to think about words that we associate with the different operations. In the equation that you see right here that I'm circling, there are different ways that you can read that with key words that indicate that we are adding. It could read a number plus 5, the sum of a number and 5, and typically with this phrase, the sum of a number, the equation will actually be in parentheses. A number increased by 5, 5 more than a number, 5 added to a number. When you see these words, you always know that it's going to indicate an addition equation. Let's look at this one. This equation, there are different ways that we can read it. They would indicate to us that we are going to be subtracting. We could say a number minus 10. There's an obvious one. A number decreased by 10. Notice with the next two equations that it actually begins with 10, which is at the end of the equation. So when you read these phrases, it actually flips the order that you write it. 10 less than a number, 10 subtracted from a number. When you write those, you actually write the 10 at the end. The next one we have here is a multiplication expression. There are 4 different ways we could read this. 2 times a number, the product of 2 and a number, and specifically because we're multiplying times 2, this could read double a number or twice a number. All of these words are words associated with multiplication. And our next algebraic expression, this simply says half of a number or 1/2 of a number. That is when you're dividing by 2. And this one reads a number squared. When looking at key terms associated with division, we could read this expression as a number divided by 4, pretty obvious, or a number separated into 4 groups. We just wanted to look at these key words that are associated with the different operations so that now we can look at math in the real world and see how to translate them and then to solve them. In our first example, this is not on your notes, but we're just going to practice a little bit of what we were talking about. If it reads 8 more than the product of a number and 4, first we have 8. More than is an indication to add. Product means multiplication. It says the product of a number and 4. Rewrite that as 4 times a number. The coefficient is always written first. Twice the sum of a number and 5. Twice is a word that we learned indicates to multiply times 2. So now we're multiplying something times 2. The phrase the sum of tells us that we have an addition in parentheses, which changes the order of operations. The sum of a number and 5. So this says 2 times the sum of, or twice the sum of a number and 5. Just going to flip through these other examples that you can see on the PowerPoint as you go through it. 7 more than, so we know that we're going to add 2 times a number. The square of the product of 6 and a number. The square of means we're using an exponent. Product means we're going to multiply. So when we write this as an algebraic expression, we have to write 6 times a number, but we want the whole thing squared, so it has to go inside the parentheses to indicate that. On your next page of notes, we're going to translate and solve. Find 3 consecutive integers whose sum is 51. When you see equation or examples like this, you need to look carefully to see what it is asking you. In this one, it says consecutive integers. You will also see consecutive even integers, or you will see consecutive odd integers. When referring to consecutive integers, we know that we are counting by 1, like 10, 11, 12, 13. Of course, when we're counting by consecutive even integers, we're counting by 2's with even numbers, 2, 4, 6, 8. If it is consecutive odd integers, again, you are counting by 2, but with odd numbers, 1, 3, 5, 7. To understand that helps us to set up our equation. We know here that we're looking for consecutive integers, so we're counting by 1. We always give us a variable for the first integer. Now, since it's consecutive integers and the next number is going to be 1 more than the first one, we're going to write the second number as n plus 1. For the next consecutive integer, it's going to be the original number plus 2. Then it says whose sum, well, the word sum indicates to us that we're adding these three integers together, whose sum is equals 51. Now with a commutative property, we can look up here and we can regroup like terms, because this is addition and we can do that with addition. We have an n plus an n plus an n. We're regrouping all the n's together. That's 1n plus 1n plus 1n. And then we can group together 1 plus 2. Now we simply create a two-step equation. We have 1n plus 1n plus 1n, which is 3n. 1 plus 2 is 3, equals 51. In our two-step equation, we subtract for 3 from both sides of the equation. And now we divide both sides by 3, and we know that our first number is 16. I should back up so that those aren't on the screen. They're kind of in the way. Now we know that the first number is 16, but we look back to what it's asking for. It said find 3 consecutive integers. So you found the first number, and now 17, 18. We're counting by ones. N stood for 16. This expression stood for 17. This expression stood for 18. And if you add all of those together, you get 51. In the next example, you will see that it says 2 consecutive even integers. So in this scenario, we are counting by 2's. It's asking for only 2 numbers, so our first number is n. Our second one, since we're counting even numbers, we're counting by 2, we're going to say n plus 2. It's the original number plus 2. Now let's see what it's asking us to do. Such that the sum tells us that we're adding, of the larger, and of course the larger number is going to be the one at the end, and 3 times the smaller. 3 times the smaller. The original number is the smaller one, so we need to multiply that one times 3, is 234. Now again, with the commutative property, we look for like terms and combine them. We have 3n and 1n, which is 4n, plus 2 equals 234. We subtract 2 from both sides of the equation. Sorry about that. 232. Then when we divide 232 divided by 4, we find out that it should be 58. 58 is the first number, but then remember, we want to find both numbers. So if 58 is the first number and we're counting by consecutive even integers, the next one would be 60, or the original number plus 2. So our answers were 58 and 60. In our last example, Jan's age is 3 years less than twice Trit's age. The sum of their ages is 30. Find their ages. We have 2 people, so we're going to have a variable to stand for one of them. I'm just going to use n. We know that the other one is 3 years less than. That phrase less than means you put the 3 at the end in subtraction, so -3. Then it says twice Trit's age. Well, Trit's age was the first one, so we want to do twice Trit's age. 3 less than twice Trit's age. So that represents Jan's age. The sum of their ages is 30. Again, with a commutative property, we look for like terms and combine them. We get 3n minus 30, 3 equals 30. We add 3 to both sides. 3n equals 33, so we know one of their ages is 11. To find the age of the other one, we take the 11 and we plug it back into this expression that represented the second person's age. That would be 2 times 11 minus 3, which is 22 minus 3, which is 19. So we know their ages are 11 and 19. That concludes our lesson on creating and solving expressions.